Welcome to another Mr. Paul video. I'm Mr. Paul. Today we're learning about 5.1, writing equations from situations, namely tables, okay? But over the next couple of videos, we'll be discussing how do you write equations in the form of y equals mx plus b, meaning how do you write an equation in slope-intercept form given different pieces of information. This is a little bit different than what we've been doing in a sense that we were given an equation and we'd have to create some stuff. We would create a table, we would create a graph, we would create some information. But now, can we take that information and work backwards? Can we take some information and be able to generate an equation? So the overall goal for today is to create a y equals mx plus b equation. So just a little bit of review. The slope-intercept form takes this general stance, y equals mx plus b, where the m stands for the slope. It's the letter that represents slope, and the b represents the y-intercept. Well, this is what they look like. Well, if we're talking about a y-intercept, it could show up as b equals some number, right, the question, or 0 comma b, meaning this is some coordinate where x is 0 and y is some number, and that some number will be the letter b. Our slope will show up as a fraction, as a one component in the numerator, which is a rise, and the number that shows up in the denominator is the run. We came from the change in y over the change in x. The rise is the change in y, the change in the y direction, right along the y-axis. The run is the change in the x-axis. Okay? So what kind of information can they give us? Well, we're going to start out with what would happen if I gave you, what if the slope, I straight told you, was 1/2, and the y-intercept is equal to 5. Could you generate an equation that looks like this given the slope and the y-intercept of 5? Well, let's just go back and think about it. If the form has to be y equals mx plus b, the form has to look like this. What information am I giving you? What information is the problem giving you? Well, let's think about it. The slope is m. The slope is m. The y-intercept is b. So I'm rewriting this equation knowing what m is equal to and knowing what b is equal to. So I can rewrite this as if in m, I'm going to write 1/2. This is 1/2. And b, I can rewrite with a 5 there. So if they're looking for the equation where the slope is equal to 1/2 and the y-intercept is 5, I can rewrite this knowing that the m is 1/2 and the b is 5. So the solution would be y equals 1/2, because my m was 1/2, x plus, now b is equal to 5, so plus 5. This would be the solution to the question, write an equation. Write an equation in the form y equals mx plus b, where m is the slope and b is the y-intercept. Let's try another example. Suppose I gave you an example where the slope is equal to -3/4 and the y-intercept is equal to -2. -2. Can we create an equation that looks like slope-intercept form? That's y equals mx plus b. Well, what information am I giving you? What information is the problem giving you? Well, once again, the slope is still our m. Oops, I wrote b, but it's actually m. The slope is m, and the y-intercept is b. When they're giving us the y-intercept, what they're actually giving us is our b. So we can think of this as like -2. And we can think of the m as -3/4. So if we're going to rewrite this, y equals -3/4x plus a -2. This plus a negative 2 is not clean. That's not how math writes this. We don't write plus negative 2. Adding a negative is the same thing as subtracting. So the more accurate answer, y equals negative 3/4 x minus 2. Math likes writing stuff in operations. So they aren't going to say plus a negative 2. They're just going to say minus 2. So this would be your answer. But do understand that if you wrote plus negative 2, you're still on the right track. Just got to clean something small up. Okay? What happens if they don't give you the slope and the y-intercept? Well, let's try this. Erase this. What if they gave you a table? Here's an example for our table. We have an x and a y. We have 0, 1, 2, 3. We have 5, 7, 9, and 11. What if I gave you a table? What if the problem gave you a table? How could we get after what M is and what B is? If we knew these two pieces of information, we have a problem just like we did in the previous two examples. The question is how do we get the M and how do we get the B from the table? We can use this back referencing the y equals mx plus b and what things look like. So let's start off with the b. The b is the easiest to see. We know that b's look like some sort of coordinate where x is 0 and whatever's in the y location when x is equal to 0 is going to be my b. So I'm looking at my table for when x is 0. Can you find it? Can you find the 0 when x is equal to 0? Well, if when x is 0, I'm looking at this location right here. When x is 0, y is 5. So what that means is this location right here, 0, 5, I know that my b has to be 5. Because I know my y-intercept looks like 0, 5. 0, 5. 0, b. This is b right here. My b is 5. That's how I can find it in my table. But what about my m? Well, if we go back to this definition of the slope, the change in y over the change in x's, we have to study how the x's and the y's are changing. Well, to get from 0 to 1, you have to add 1. To get from 1 to 2, you have to add 1. And from 2 to 3, you have to add 1. And to get from 5 to 7, we're adding 2. 7 to 9, we're adding 2. And 9 to 11, we're adding 2. Now we're studying the change in y over the change in x. These numbers here represent the change in x, right? These are how my x's are changing each time. These numbers down here represent the change in y. Because those are how my y's are changing each time. So when the question is, what is the change in y over the change in x? That's my slope. I want to look at this number, the change in y, over the change in x. So my change in y is 2. My change in x is 1. I now know that my slope is 2 over 1. I have my slope, I have my b, I have my line. Y equals mx plus b. But I know what my m is. That's 2 over 1. Y equals 2 over 1 x plus b. Now b was 5, so plus 5. Let's do one more example. Let me erase all this. Here's another example. Here's my x's, here's my y's. What if these numbers went 0, 2, 4, 6, and this number went 1, 2, 3, 4? Can we find out what m is equal to and what b is equal to? If we could do that, we'd have an equation. We have to figure out what m and b are. Well, let's go to the easiest one. B. B looks like 0, comma b. I want to know the coordinates where x is 0, and whatever the y is at when x is 0 is going to be my b. So I'm coming over to my table, and when x is 0, y is 1. I'm looking at this location right here. These are coordinates. X, comma y, 0, comma 1. 0, comma 1. My b is 1. If I want to get after my m, I have to study the change in the y over the change in the x, meaning I want to know how this is changing. This, to get from 0 to 2, is plus 2. From 2 to 4, plus 2. From 4 to 6, plus 2. From 1 to 2 is plus 1. From 2 to 3, plus 1. From 3 to 4, plus 1. So when we're studying the m, we want to know the change in y over the change in x. Well, the change in y, they're these numbers down here. These are changes in y's. And we're comparing them to the change in x, which are these numbers up here. So my change in y is 1. My change in x is 2. My slope is my change in y over my change in x, which is 1 over 2. If I have an m and I have a b, I have a line. My line looks like y equals mx plus b. I know what m is and I know what b is. Y equals 1/2 x plus 1. Hopefully after this video, you're able to do two things. You're able to write an equation given a table, and you're able to write an equation if I gave you the slope and I gave you the y-intercept. That's all for today's video. Peace.